In this nested loop configuration, this smaller loop inside is usually referred to as the inner loop. Every time this outer loop steps inside, it would restart this inner loop's counter to 0 again, forcing it to print this high message 3 times, which means this outer loop would cause this message to be repeated 3 times again and again, 3 consecutive times. That's why this message would be printed out 9 times in total. But let's trace this program step by step and watch our variables I and j change as we go. Starting with the outer loop, I is initialized to 0, setting its value to 0. And then the next thing that happens is we check if I is less than 3. In this case it is, so it steps inside and goes into this inner loop. What happens now is that j gets initialized to 0, getting that value, and then we check if j is less than 3, which it is. So we step inside the inner loop, printing out the statement hi. And then we reach the end of the inner loop, so we go back up and check and increment j by 1, changing its value from 0 to 1. And then once we increment it, we check that j is still less than 3, which in this case it is, so we step inside the loop again and we print out another hi. We reach the end of the inner loop, so we go back up and add one more to j. Then we check if j is still less than 3, which it is, so we step inside the loop again and we print out hi one more time. This time we reach the end of the loop, we go back up and increment j by 1, making it 3, so when we check that j is less than 3 this time, it's no longer true. So that just jumps all the way to the end of this inner loop and continues from there. And since there's nothing after this inner loop, so we reach this closing bracket of the outer loop, which means we go back up and we increment I this time. I changes from 0 to 1. So we check if I is still less than 3, which it is in that case, and that means we step into that loop. Now that we've stepped into this outer loop, we see this inner loop all over again. So we start from the beginning, including the initialization step, and j goes back to 0. So we check if j is less than 3, which it is, and then we start printing again. So hi gets printed out, and then we reach the closing bracket of the inner loop, so we go back up and increment j, going from 0 to 1, and then checking if it's less than 3, which it is, so we print out hi again, and then we end the inner loop again, go back up, increment j to 2, check if it's less than 3, which it is, so we print out hi again. And then we repeat this until we get j++ to make our value 3. So when we check if j is less than 3, which it's not in the case, we don't print anything, and we skip to the closing bracket of the inner loop. And then we move on, we don't have anything else to do, so we reach the closing bracket of the outer loop. But I is still less than 3, so we go back up, we increment I to make it 2, and we check if I is less than 3 or not, which in this case it is, so we step into the inner loop again, initializing j again, making it 0, and then because 0 is less than 3, so we start printing all over again. And this would force our inner loop to go over and over its normal cycle and print out hi 3 times again. Now after the inner loop reaches the value of 3, this condition becomes false, and we skip to the end, and then we reach the closing bracket of the outer loop. And we go back up and increment I, making it 3 this time, which is no longer less than 3, so it doesn't even step into this inner loop anymore. And it just simply jumps to the closing bracket of the outer loop, and the program ends. Now if you've noticed, I changed from 0 to 3, and every time I had a value, j changed from 0 to 3. This is the idea of nested loops, where you could use I and j interchangeably inside the inner loop in many occasions. Let's see how we could use nested loops to navigate through a two-dimensional array, for example. Going back to our two-dimensional grid here, we want to see how we can go through every single number in this two-dimensional array. We already know that if we wanted to go through every item in a single row, we can simply write a loop for that. This loop, for example, would go through every single item in row with index 0, which means it would count all these numbers, and because it's adding them to total, now by the end of this loop, we'd have the value of total equal to the sum of the items in that row. If we wanted to add all the other rows, we could simply write a loop for each row. The only difference is the index here, matching the index of the row that we're interested in. So once we run this code, it would go through every single row and then every single item in that row and add them up until we get the total value we want. However, if you noticed, all these loops are almost identical except for that index, which happens to change from 0 to 3. That looks like something we could use a loop for. If we surround one of those loops with another loop and use its loop counter instead of this index, it would do the exact same thing that this code is doing. So if we replace this code with something that looks like this, where we have this nested loop configuration here, one that uses the loop counter I and the other that uses the loop counter j. And if we try to access grades of I and j, this would eventually add all the items in the two-dimensional array. So running this code, the inner loop would go through every single item in a row, and then the outer loop would make sure that we switch to the next row, and then the inner loop would go through every item in it again, and that way we can guarantee that by the end of the code we've seen every single item in the grid. And because every time we're adding the grades into our variable total, by the end of this nested loop configuration, total would have the sum of every single number in this two-dimensional array. Perfect. You can do a lot more than just add the numbers. You could, for example, try to find the minimum number and the maximum number in a two-dimensional array using this nested loop configuration.